Hello, my name is Janice Reutt-Robey. I'm the director of the University of Maryland Materials Research Science and Engineering Center. Our center is an interdisciplinary research center. We have faculty from 6 academic departments at the university and even faculty from other universities come together and work on research projects, all of which use an interdisciplinary approach. And we also couple this with our education programs. And so we have extensive educational programs within the university and also to the outer community. Well, the center was funded originally through funding from the National Science Foundation, and that still makes up essentially the majority of our support. But we also get matching support from the university, which is primarily through state funding. And through the successes of our research, we've also been able to go out to other agencies and organizations for support. Well, our MRSEC has clearly a materials focus, and we're actually focused on what I would call cutting-edge nanostructured materials. We're interested in essentially 2 classes of materials. One involves layered material structures, where we're particularly interested at the new interfaces or contacts between materials and how those new interfaces give functional electronic properties. And the materials that go into those structures are usually inorganic layered materials and also organic materials. When I say organic materials, what I'm really saying is materials that are comprised of molecules which behave as semiconductors. So that's one example. The other example are materials that are oxide materials. We have a whole thrust that focuses on complex oxide materials, and those materials are being developed for memory applications. In some cases, those are also layered material structures. Okay, well, I would say sort of 2 levels, I guess. In our research thrust on low-dimensional interfaces, as I said, it's these layered material structures. Those are being used increasingly in electronic devices, and so the kind of a dream is to replace computers, for instance, which are now based on semiconductors. I won't say replace them, but basically to complement those materials, to use components that are based on these faster and cheaper organic layered materials. So that's one aspect. We also have energy-related aspects, and so the kind of structures that we're making are very important for energy applications. They're being used already in solar cell materials, energy storage devices, battery applications, things of that nature. So that's one aspect. For the oxide materials, those are being used primarily for what I would say being developed primarily for memory devices, although there are other applications as well. And to develop these materials and these material properties, a lot of the structures that we're really pushing the materials to are nanoscale structures. And so to make this research work, our center is involved on several different levels. One is you need to be able to create materials that are uniquely nanostructured. And this is a complicated problem because chemists are used to thinking about how to make things on an extremely small scale, and kind of conventional science, kind of old school materials engineering would be to make very thick or big structures. And so figuring out how to assemble materials on this nanoscale is really a challenge, and our center is I think, a leader in that area. Additionally, not only to make the materials, one has to develop tools to really measure the materials and direct them into the correct structure, and has to develop theoretical models to describe whether or not you can even make materials into these structures. And I think one of the real, what I would say, distinguishing features of our center is that we have this very close coupling between experiment and theory, so that we can not only demonstrate materials, but we can come up with new theoretical concepts so that we can create materials and give recipes to others so that they can create their own materials. That's one key part. And the other part is our center, we have a number of scientists, as I said, from different academic departments, and a number of us are engaged in developing new instrumentation. So our center is particularly well known for developing scanning probe microscopy tools to measure small structures and watch it dynamically. Watch how structure changes under different, what we would say, stressors. It's natural science, engineering, mathematics. So we have chemistry, we have physics, we have material science and engineering, we have chemical engineering. Well, our education programs are really quite extensive, and so they're the obvious educational programs that you might imagine that we have at a university. And those are training our graduate students and undergraduate students with cutting-edge tools, learning to use and develop the latest equipment and apply it to new materials. And so that's kind of what we do, and I think everyone would expect us to do that. But our center is also very involved with what we call broader education. So we are actively involved with our surrounding schools and even homeschoolers at the K-12 level, where we have teams of our scientists and students that go to schools and essentially lead hands-on scientific activities, even in some cases develop some curriculum projects that are actually used directly in those schools. We also have groups of students and their teachers who come to our center and engage in workshops and activities. And so it's very reciprocal type of an experience, and I think it's actually beneficial to all involved, students, faculty, at all levels. And so one of the things that we really like about it is we say that the research and educational activity of our center is highly integrative. You know, it brings together people kind of with many different disciplines and also at all different educational levels. Well, it's very important to the center goals. As big as we are as a center, there are techniques and tools that we might not have immediately available. We're blessed in our location in the Washington, D.C. area because we're near a number of national laboratories. So we have very active collaborations, for instance, with the Naval Research Lab, the National Institutes of Standards and Technology, just to name two. So those are two very active collaborations. They're research institutions in the area. And I should also mention that one aspect of our center is that we have a number of major shared research instruments that we operate as shared facilities. And each of these shared instruments essentially becomes a collaborative research facility where we'll have research going on there. We have knowledgeable people operating these instruments, and then we'll bring it, and then we will make them available to researchers at other universities and other organizations, and they'll come in, and it becomes a recipe for research interaction, really. Well, first, if you're a graduate student interested in our center, the first thing I would do is invite you to come to our seminars. We have a number of seminars that are open, and so that's kind of a good way to come in, sort of see what the center is about, and hear about a little bit about the research going on. You're also welcome to contact me or any of the faculty members and students listed on our web page, and that's kind of a good way to find out about sort of the details of the projects. And there are many different entry points. So we have undergraduates working in our labs during the center. We have summer programs for students at the university and outside. We run a very active REU program. Actually, if you're even a high school student, we have summer programs for high school and for that matter, even middle school students. So as I said, we are very integrative program.